Hey guys, so my name is Trey Patel and I am on FTC Team 2845 Team Duct Tape, and in this video I'll explain how to design your drivetrain. So some facts about our team. So this year's FTC Challenge Ultimate Goal will be our team's 13th season. So our team's been around for a while. So this season we will have 11 members, and we may have some more. We don't know yet. And also another cool fact is our team meets at Amrock Fab Lab, which is located in a mall that has a full FRC field, full FTC field, FLL tables, like 6 3D printers. Like, we have access to everything. So if your team is in Florida or is like stopping by, like, you guys should check it out because it's a pretty neat place. And at the bottom, so that's a team photo from last season, and to the right, that's what Amrock Fab Lab looks from the outside. Since it's in a mall, so you have huge glass panels that, like, so essentially everyone who's shopping in the mall can actually see straight through, like, what you're working on. It's pretty cool. So essentially, when you're designing your drivetrain, you have 3 different options. So you can either build a fully custom robot or drivetrain, you can go with the kit, or you can use vendor parts. Technically, there's the fourth where you can use a mixture of like vendor parts and a custom robot or whatever. So, some of the things for the custom drivetrain are, in order for you to create a custom drivetrain, you have to have access to a machine shop with, like, it honestly depends on your design. So, like, some designs are so simple that you can just use like a drill press and a bandsaw, and then there's some designs that require like a laser cutter and a CNC router. So ultimately, it depends on what you have access to. So the next point is you have to have a CAD model if you're going fully custom. So, like, if your bearing hole has to be like 3 inches to the right and 2 inches up from like one corner, you need that to be precise, and the only way you can do that is essentially with CAD. So having a CAD model is, I don't know how you can get away with not having a CAD model. I don't think you can, but definitely have a CAD model. And so one other thing that I've noticed is the years that teams, like a good majority of teams, go with fully custom drivetrains are the years that, like, the drivetrain is really important and it plays like a really huge role. So games like Velocity Vortex, where good majority of teams use the mechanic wheels because you had to pick up the wiffle balls. A good majority of teams weren't fully custom for the drivetrain because having your location, your robot's location around the field, it didn't have to move fast, but it had to be precise, like where it's going to collect the ball. And ultimately, there's ways to get around, like not going fully custom. Like, you could just like have a wire collector or whatever, but that's not the point I'm trying to make. Like, the drivetrain is essentially the most important because everything else on your robot is based off of the drivetrain. So the next thing I want to talk about is using a kit. So when I talk about kit, I'm talking about things such as the Go Build Strafer chassis or the Andy Mark tile runner or things like that. So where you literally just pay and they'll send you everything you need to build the drivetrain. So, one, they're very reliable. So these manufacturers have, like, actually tested them and they're pretty reliable. Like, I don't think I've ever heard of a team like actually complain about using them. So I guess that's a good thing. One drawback, it ultimately depends on your team's budget and other factors, is they normally start from around $200, and that's without the wheels. So that's one thing to consider. Also, you don't have to cut it out. So one of the benefits of going with a kit is that the drivetrain is fully headed out and the manufacturers provide it on their website. So that you just save like hours of time when you purchase the kit. Also, so another observation is the kits, like especially the Go Build a Strafer chassis, like that was like really popular in Skystone when it was released, and what I've noticed is a good majority of the rookie teams, that's what they went for. And also, like, I noticed that teams like that wanted to focus on other parts of the robot. So like they wanted to focus on the intake for collecting the stones for last season, and like having the linear slides to take the stone and stack it. That's what most of the teams, like, that's what I've noticed, like most of the teams in our area, that's what they focused on. So they just went with the chassis because it saved them time overall. So the next topic I'm going to talk about is using vendor parts. So what I mean by this, I mean using parts from either like Actobotics, Go Build a, Tetrix, Andy Mark, Rev Robotics. There's like so many brands that you can choose from, and you can use several brands, and good majority of the brands actually sell adapters. So like you can convert like a Tetrix beam hole pattern to an Actobotics beam or channel, or you can. Most of these vendors have already thought of ways that you can implement other vendors' designs. So the one thing about the vendor's parts, when you use them to create your drivetrain, is you do not have to have a CAD model, but it'd be nice to have a CAD model. So the only reason why it'd be nice is, let's say you don't have any of the parts and you want to order it all. So if you have it fully CADed out, you can literally just order those parts and then assemble it, and your CAD would act as instructions. Also with the CAD, you can see like if like let's say one channel is going to collide with another channel, which in CAD they can overlap if you don't have it constrained right. But in real life, obviously you can't have a middle plate, you can't have a Tetrix channel and a Tetrix channel inside. Like that's literally impossible. So yeah. So then another thing is that some teams feel that using like the vendor's parts to create their own drivetrain, it saves them money that when compared to the kit. And yeah, it's like for obvious reasons, like maybe just buying everything you need for the drivetrain. I don't know. It depends. It depends on your drivetrain. Like if you're going with Canon, they're gonna cost more because then you have to have 4 motors. You also have to have Mecanum wheels, which most of the Mecanum wheels start at I think $70. I think Rev's Mecanum wheels I believe are the cheapest option, but also they're smaller. They're smaller and not as wide. Yeah. So like yeah, it ultimately depends on like what your drivetrain you're creating and like the cost, and that'll ultimately it's like your team's decision and what they choose. And some of the parts can be bulky because remember you're using these vendor parts and they're not specifically designed for your like especially like what you're doing. So if you're doing a drop down intake and you're using like 2 Actobotics channels with bearings inside, yes, it may be a bit too bulky, but you're using a universal system. It wasn't designed for you to have a drop-in collector like that. So you can use their parts to your advantage, and there's some things that you may have to manufacture, and you can either use 3D printers, create it in a shop, or you can change your design so that it can rely on these vendor parts to simplify your build process. So next, we're going to talk about the different types of wheels. So, okay, so these are your standard, so this is specifically the Tetrix standard wheel. These are Tetrix the treads, which I don't think they're rubber. I think they're plastic. I'm not 100% sure. I don't think our team's ever used them. These are the Tetrix Omni wheels, and this is the Go Build a Mecanum wheel. So again, it depends on the game and it depends on your team strategy. So if you want your robot to move in every single direction, Mecanums or Omni wheels are the way to go. Because Mecanum wheels, if you have one motor per wheel, then you can control how the wheels rotate, and since they have the 45-degree rollers, since they're on the slant, then you can literally move in every single direction, which is pretty cool. And especially this season, like where you're not going to have other robots on the field until maybe later on, like past January, this is going to be a really good option because you can't be pushed around because you're the only robot on the field. And yeah, so essentially if you want a robot that can move around pretty well, Mecanums are the way to go. So you can also replicate everything you're doing with a cam wheel, with the Omni wheel. It's just the setup is a bit different because there's like so many different options. So there's an H drive with Omni wheels, and there's I don't know exactly what it's called, but like you have each one on one corner. Each one is on an angle on every single corner of the robot, so essentially you'd have a square frame. And those are not the only uses for the Omni wheels. So you can also use Omni wheels for if you pair them with like normal wheels, because then if you use, let's say you're doing with your back two wheels that are driven that actually have motor output, are these wheels, the Tetrix standard traction wheels, and in the front you have these Omni wheels, and they're unpowered, then your turning radius would just be your back two wheels, your back two Tetrix traction wheels, because these Omni wheels have side rollers on them, and those side rollers allow the robot to turn easily. So yeah, the next thing is using the treads, and I don't think I've ever seen Team use them. I think the one year that I've actually seen a tread FTC robot is during the game Rescue, where the teams had to climb the mountain, which that was the game that most teams went with that, because like that's what seemed logical, like to climb. Like, I don't know what the angle was. I wasn't in FTC back then, but yeah, it ultimately depends on your game. And the thing with the treads, the tank treads, are that you typically go slow with them, and because you don't want the track to you don't want the treads to come off, because then you can't move. Yeah, I guess I'll move on. So some of the ways of transferring power are, as you can see in the pictures. The first one is direct drive, where you're using the output shaft of the motor and you're literally attaching a wheel to it. It's the most simple, it's literally the simplest way of like doing a drivetrain. Next is to the right of that is a sprocket and chain, where with this you can actually change the ratio if you want it slower or faster. Yeah, like, so it's essentially you'd attach one of the sprockets straight to the motor through a hub, and the other sprocket would be attached to a shaft. which is attached to your wheel, and then hopefully you would support that on both sides, or at least one side. Yeah. So essentially the next one, so the bottom left image is a belt, and belts and pulleys, they essentially work the same way that sprockets work, except the only difference is with the belt, you normally keep that as one loop. Rather than the chain, you can break it and change it to whatever length you want. The last system is gears, and essentially you just use one gear would be attached to the motor, and then you can run a gear train and to your output, or to the shaft for your wheel. The one thing you may want to worry about with the gears is slipping. You don't want your gears to slip, because then it won't be able to transfer power. Yeah, so the belt, something you may want to worry about is keeping it tensioned. And same thing for the chain. You definitely want that tensioned. With the belt especially, you want that to be tensioned, and you don't want to have too big of with the belt. Here's how it works. You don't want it to be too small. You definitely don't want it to be too small. But if you have it too big, you can get away with tensioning it, but it's just easier to get the right size from the beginning. Like most of these vendors, like they offer a lot of sizes, so yeah, as long as you just get the right size, don't get too big, and definitely don't get too small. Yeah, I guess that's it on ways of transferring power. I think those are the main ways. Yeah. Oh yeah. So this is a drivetrain that I had created over the summer. It's pretty basic. So your middle wheel is the Tetrix traction wheel, and on the outside is an Omni wheel on each side, and the same thing for the other side. I probably should have put two Omni wheels, so a total of four Omni wheels per side, just to help. And essentially, the one good thing about this drivetrain is that your turning radius would be the exact center, which is what I hope most teams would go for. It ultimately depends on your robot design and what you end up doing. But yeah, this is probably the most ideal way of designing a 6-wheel drive. And then if you wanted like a normal 6-wheel drive, you can replace these outer Omni wheels with the same Tetrix wheels. And yeah, since they're the same size, you can just replace them and you'll have 6-wheel drive. And the teams I've noticed that do the 6-wheel drive are the teams that either they typically run their robot pretty fast, or they have it run pretty slow, but as it's able to push other robots. So that's, I guess, more of a defense robot. Then there's this design, which essentially exact same thing, except this is an 8-wheel drive. And the cool thing about this design is that GoBuilda creates these brackets, these channels that have a 45-degree angle, and they're open on the side, so it's only the top that's closed. So essentially, you can run their Rhino wheels on the inside, which I found pretty cool. Because then, if you could run that, that means your entire width of the one side of the drivetrain would be smaller than a typical drivetrain. Which most teams, they try, especially with the teams that go fully custom, this is what they try achieving. And it's really nice that GoBuilda was able to design it like this. And so, as I was talking earlier, this would be an example of a fully, or not fully, actually no, this would be the mixture between a fully custom and a using vendor parts. So yeah. Next is this Mecanum drive that I created over the summer, and essentially it uses, so Mecanum wheels, you have to have four wheels, or yes, you have to have 4 Mecanum wheels, but you also have to have 4 motors. So these motors have pinion gears on the inside, and Actirobotics designed this system so perfectly so that you can have a one-to-one mesh between every single hole in the Actirobotics channel. So from the front motors, you're able to transfer power all the way to the very front, which it's pretty neat, because then you have your entire front where it's empty, because then you don't have any axles sticking out or anything like that. And yeah, so then this is the example of using the kit. So this is the brand new Go Build a Kit. They're V2, and this uses their new planetary, actually no, they've had these planetary motors for a while now, but it uses their new miter gears, and it looks like they redid their mechanisms. I don't know, they look like they redid them, and they look pretty nice. Yeah. Yeah, I literally, this is like the first time I've seen the new version of the chassis. And unlike the previous version, these are running a 1-to-1. So I believe miter gears, by definition, are gears that run at a 90-degree angle. So that means they have 45-degree slots on them. And they're essentially able to transfer power 90 degrees. So that's how they're able to fit these motors on the inside of the channel, and then transfer power to the shaft that's powering the wheel. So yeah, if you guys have any other questions, please reach out to us. Our email is tdt2845@gmail.com. Definitely check out our Instagram page. I believe it's Team Duct Tape 2845. There we actually, over the summer, we ran a pretty long class on drivetrain design, and you should be able to see it on our IGTV. And yeah, if you have any other questions, just email us or DM us on Instagram. That same username for Instagram should be our same for Facebook and Twitter. So yeah, if you have any other questions, please contact us. Thanks.